Hi everyone. So let's start this session. In this session, we are going to discuss the weekly quiz 16. In this weekly quiz, we have total 21 questions from group theory. Okay. So before you watch this session, before you watch this recording, so I want to suggest that first you attempt this weekly quiz. Okay. So first you attempt, then you watch this session. Then you watch this solution, this discussion you watch after attempting the weekly quiz 16 for your benefit. Okay, for maximum benefit. So now let's start this session. Let's start this question number 1. So this is your weekly quiz 16, question number 1 from group theory. The question is saying that G is a group and Kelly table is given. Okay, so G is a group, remember, and this Kelly table is given to you. Now the question is asking. So what the question is asking, let's solve it. Okay, so here this Kelly table of a group G is given to you, and the question is asking some details about G. Which of them is true about G? So let's see. Now, so first of all, you tell me, is this G a abelian group? How will you check from the Kelly table? How will you check for abelian group? Like if this Kelly table is given to you, this Kelly table, if this is given to you, then how to check from this Kelly table? How to check this commutative property? How to check commutative property? Tell me. If you want to check commutative property from a Kelly table, commutative property, if you want to check, then what you will do? Very simple. This Kelly table M is given to you. I can say this Kelly table M is given to you. This structure will be commutative. Okay. This structure will be commutative if M is equal to M transpose, right? I can simply say that commutative property, I can say that M is commutative, or I can say this structure is commutative. Let's assume Kelly table of this structure, some structure. Okay, Kelly table of this structure is given to you. This is some structure. This may or may not be group, right? Yes or no? This can be any algebraic structure. This is some structure. This is some structure, some structure. Remember, this may or may not be group. Tell me one thing. Do we create Kelly table for a group, or can we create Kelly table for monoid also? Like if some structure is not a group, can we create Kelly table for that? Yes, we can do that. Okay. I told you that Kelly table, this is just a table, nothing else. Okay. This table, this representation, this I can say this array representation, 2-dimensional array representation, or I can say this matrix representation. This is called Kelly table, and you can create Kelly table for group. You can also create Kelly table if some structure is not a group. Okay, if some structure is not a group, then also you can create Kelly table. So this Kelly table you can create for any structure. Now let's assume you have this structure s comma hashtag hash, and this is your structure, and this Kelly table is given to you. Then when can I say this structure is commutative? I can say this s comma hash, this is commutative. This is commutative if and only if this Kelly table is symmetric. If and only if M is symmetric. Okay, and what that means? M is symmetric. What that means? That means in this M, ith row, in this M, remember, ith row is equal to ith column. Okay, in this M, ith row is equal to ith column. So very simple. Or I can say in the linear algebra you have seen this M is equal to M transpose. Okay, this is the definition of symmetric matrix, that M is equal to M transpose. Or you can say that ith row is equal to ith column. So let's check. Can I say ith row is equal to ith column here in this? So you check. The first row is same as first column. Yes. What about second row? Is second row same as second column? See, second row is not same as second column. You can notice this is your second row. This is the second row. Okay, and you can see this second row is not same as this second column. Okay, they are different. This is your second column. This is your second column. So you can see that second row is not same as second column. For example, look at this. For example, look at this. Like I can say that 3 star 2. What is that? 3 star 2. That is 8, right? This is your 8. 3 star 2. So that is 8. And what is 2 star 3? If you look, 2 star 3, that is 4. So you can notice they are different. They are different. You can easily notice that. Is G a abelian group? The answer is no, because you can simply say that 2 star 3, that is not same as 3 star 2. Okay, so I can say this is not a abelian group. Now, what about this one? Remember, the question is asking for true statements. Okay, the question is not asking for false. The question is asking for true statement. What can you say about inverse of 6? In Kelly table, how will you find the inverse? First, to tell me, in the Kelly table, how will you find, if you have Kelly table, if this Kelly table is given to you, okay, if this Kelly table M is given to you, then tell me, how will you find the identity element? Tell me, how will you find the identity element? In this Kelly table, how will you find the identity element? Identity element E. How will you find that? Very simple. That the row of E will be same as the header and the column of E will be same as the header. So you can see that the identity element has this structure. This element will have this structure, that I can say this. Okay, so I am saying that this identity element will have this structure, that if this is like, I can say A1, A2, and so on, AN, then remember, this row of E also will be same. Row of E also will be same. And also remember the column. Like for example, I can say, if you see the column of E, that will be same as this one. I can say that this row of identity element will be same as this header. Okay, so these will be same. I can say this is your header. Okay, let's call it header. Let's call it header. So you can see these two will be same. These two will be same. This and this header. These two will be same. And also the column of this identity element. The column of this identity element will be same as this one. Like for example, here if you have like B1, E, B2, and so on. Okay, or maybe or you can just simply write like that. That A1, A2, E, and so on, AN. If you have this, then remember, I can simply say that the same thing will happen here. A1, A2, E, and so on, AN. Okay, so these two will be same. I can say this will be, this order will be same as this one. These two will be same. So this is the idea. This is how you can see the identity element. Now you tell me, how will you find the inverse? In the Kelly table, if you have identity element in this Kelly table, how will you find the inverse? Like if you have this, if I want to find A inverse, then how will you find this A inverse in the Kelly table? So very simple. You just look at this A. Okay, this is your A, and you find in this row where is E. Okay, you just find where is E, because remember, assume that A inverse is B. Assume that A inverse is B. Assume that A inverse is B. Then what will happen? If A inverse is B, then what will happen? Then AB will be equal to E, right? Okay, so AB will be equal to E. Very simple. If let's assume I'm saying that assume A inverse is B. Okay, so assume A inverse is B. Then in this situation, I can say AB will be equal to E. So you want that element such that will give you E. This element you are looking for. Okay, this element will be your A inverse. Okay, so you can simply say that this element will be your A inverse. Okay, basically you are looking for this E. Very simple. Okay, so this is how you can find the inverse. So tell me, in this one, how will you find the inverse of 6? Okay, let's see. First of all, here you can see that 1 is the identity element, because you can see this is same as this. Okay, this row is same as the header. Okay, so these two are basically same. These two are basically same. Also, you can notice that this one, 1, 2, 3, 4, 5, 6, 7, 8. This is same as this. Okay, so these two are also same. It means you have identity element. Okay, your identity element, that is 1. So here, so this is the one thing. What is the second thing? Tell me, what is the inverse of identity element? Remember, inverse of identity element will always be identity element. Inverse of identity element, that is always identity element. So inverse of 1 is equal to 1. What about inverse of 2? What can you say about inverse of 2? Here, inverse of 2, that means you look for this one. Look for identity element. Okay, because now what you got that 2 star 6 is equal to 1, and 1 is the identity element. 1 is the identity element. So from here, I can say that 2 inverse is 6. From here, you can say that 2 inverse is 6. Okay, so I can say 2 inverse is 6. First, you tell me, do I need to check is this group or not? Do I need to check this Kelly table, is this group or not? Do I need to check? No, it is already given that it is a group. It is already given to you. Okay, so don't worry about it. So 2 inverse is 6. What about 3 inverse? If 2 inverse is 6, then 6 inverse is 2. What about 3 inverse? What can you say about 3 inverse? So for 3 inverse, you just look for this. Okay, this is your 3 inverse. This will give you your 3 inverse. So from here, what you got? So this will give you your 3 inverse. So from here, you got that 3 star 7 is equal to 1. And remember, 1 is the identity element. So from here, you got that 3 inverse is 7 and 7 inverse is 3. Okay, remember. So inverse of 6 is 2. That is correct. You can find the inverse of 3. You can find the inverse of 7. What is remaining? What is the inverse of 4? Tell me. What is the inverse of 4? So 1, 1, 2. So these are over. Now, what is inverse of 4? So inverse of 4 will be 8. You can easily notice. Inverse of 4 will be 8. Okay, so automatically inverse of 8 will be 4. Inverse of 8 will be 4. Okay, which element is remaining? Did we leave any element? So you can see. Did we leave any element? Yeah, inverse of 5. What is the inverse of 5? Tell me. The inverse of 5. So you can see inverse of 5 will be 5. Inverse of 5, that is equal to 5. Okay, so very easily you can find the inverse. What about the order? How will you find the order of 6? How will you find the order of 6? Let's see this. So first of all, you tell me what is the definition of order? Like, what can you say about if you have a group? If you have a group G, then tell me what can you say about the order definition? What is the order of A? What is the order of A? So I can say that order of A, remember, there are multiple definitions. I told you there are multiple definitions for order. The one definition, that is subgroup generated by A. You find the subgroup generated by A. Okay. So that is, this is your subgroup generated by A. Subgroup generated by A. You find this, and remember, order of A will be equal to order of A will be equal to the size of this subgroup generated by A, the cardinality of this subgroup generated by A. Okay, the size of this subgroup generated by A. Very simple. Okay, so you find the subgroup generated by A and the cardinality of subgroup generated by A. I can say that cardinality of subgroup generated by A. That is your order. What is the another definition? Another definition is smallest. Another definition is smallest positive. Okay, smallest positive integer. Smallest positive integer n, such that A power n is equal to identity element. Okay, this is the definition. So smallest positive integer n, such that A power n is equal to identity element. Okay, so let's see what is the order of 6 here. So if I want to find the order of 6, then from where I will start? If I want to find the order of 6, then from where I will start? I want to find order of 6, then from 6 power 1. Okay, because remember one thing, please understand, smallest positive integer. Okay, smallest positive integer. So positive integer, it means that from 1 you have to start. Okay, so you have to start from 1. So tell me, what is 6 power 1? That always will be 6. That always will be 6. Did we get identity element? Did we get identity element? No. Okay, so should we stop? No. So let's see 6 power 2. What is 6 power 2? That is 6 star 6. Okay, let's see what is 6 power 2 here. In this one, what is 6 power 2? So you can see this is 6, 6, 6. That will be 5. This is, remember, this is your 6 power 2. This is 6 power 2. 6 power 2 is a 5. Is that identity element? Did you get identity element? So 6 power 2, that is a 5. And that is also not identity element. Okay, so let's see 6 power 3. What is 6 power 3? Remember, tell me one thing. Will you do this? 6, 6, 6. Will you do this? Will you do this? No, you don't have to do this. What you can simply do, already we know that this is 5. Already we know that this is a 5. 6 star 6. That is already 5. Okay, that is already 5. Okay, so you can just use it. You can just use it. What is 5 star 6? What is 5 star 6? So that is already 5. So you can just use it. What is 5 star 6? 5 star 6. That will be 2. Okay, so that will be 2. So this is your 5 star 6. This is the 5 star 6. So that will be 2. Did you get identity element? That is also not identity element. So I will not stop. Okay, now let's see what is 6 power 4. 6 power 4. For that, what I need to do, I can do 2 into 6. Okay, because 6 power 4, that means 6 cube star 6. That is, you already know this. This is already 2. So it simply means I want to find 2 star 6. I want to find 2 star 6. Okay. So what is 2 star 6? So you can see here 2 star 6. That is identity element. This is your 2 star 6. You got your identity element, right? So you got one which is identity element. Should I stop? Should I stop? Yes, I can stop. Now I can stop. Okay, so here you can say that what is the order of 6? What is the order of 6? Tell me. The order of 6, that will be equal to 4. Okay, because this is 4. So order of 6 is equal to 4. Very simple, right? So this is how you can do. Just go. Remember, order definition, just apply this definition, nothing else. Just apply this definition, that smallest positive integer such that you get identity element. Okay, such that you get identity element. So remember, if you want to find order, if you have a group, in this group G, if you want to find order of A, then all you have to do, if you want to find order of A, remember, then what you need to do, just start with A power 1, then go to A power 2, then go to A power 3. Okay, keep going until you get identity element. Okay, then you find A power 4, and so on. You keep going such that you get identity element. Okay, once you get identity element, so let's assume this is not identity element. 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 Okay, once you get the identity element, then you can say that order of A is equal to, here you can say order of A is equal to n. Okay, order of A is equal to n. Very simple. So this n should be the smallest positive integer. This must be the smallest, remember, very simple. This must be smallest. Don't forget about smallest. Smallest positive integer. Simple. Now let's move on. In this, so I can say order of 6 is 8. That is wrong. That statement is wrong. What about order of 5? In the same question, what can you say about order of 5? Tell me. What can I say about order of 5? So let's see. If you want to find order of 5, this is what I want. Order of 5. Then what I can do? I can start with 5 power 1. 5 power 1 is 5. That is not identity element. Okay, let's go to 5 power 2. What is 5 power 2? What is 5 power 2? Remember, 5 power 2, that means 5 star 5. What is 5 star 5? That is equal to 1. So you got identity element, right? You got identity element. So once you get identity element, you can stop. You can stop here. And you can say order of 5 is equal to 2. Okay, order of 5, that is equal to 2. It means what? Tell me. Order of 5 is equal to 2. It means what? It means 5 is inverse of 5, right? It means 5 is inverse of 5. If you see, 5 is 5 inverse. 5 is 5 inverse, right? So this happens when you have A inverse. This we have already seen, if you remember. Okay, this we have already seen, that A is equal to A inverse. That implies A square will be equal to E. And if A square is E, then A is A inverse. Okay, so this is both ways, right? Agree? Yes or no? This is both ways. This we have already seen. So the same thing is happening here. Order of 5 is 2. That simply means 5 square is 2. Okay, 5 square is 2. And that simply means that 5 is 5 inverse. So simple. All these things you can easily notice. Okay, let's move on. So this is a simple question. Ultimately, in this question, basically, we are asking how to use the Kelly table. This question is based on use of Kelly table. So I can say answer will not be A. Answer will not be this. Answer will be, I can say this and this. Answer will be B, comma D. Very simple. Remember, the question is asking for true statement. Because the question is asking for true statement, so answer will be B, comma D. If the question is asking for false statement, answer will be A, comma C. Okay, so your answer will be B, comma D. Let's move on. Let's solve this question. So in this question, a group Kelly table is given to you, but some entries are not given, right? This is partially filled Kelly table. Some entries are missing. Okay, can we fill the entries? In this table, some entries are missing. Can we fill the entries? Can we complete this table? Who is going to help us? Tell me. Who will help you completing this table? You want to completely fill this table, all the entries you want to find out. Then who will help you? This word will help you, because this is a Kelly table for a group. Okay, so this is a multiplication table for a group. So you can very easily, you can fill it. Let's fill it. So what properties of Kelly table of group you are going to use? Okay, so remember this point, that Kelly table of group, Kelly table of group. Okay, so you can use the properties of Kelly table of group. Some properties you can use, like for example, one property. What is that? One property is no repetition in any row or column. Very simple. These properties you can use. No repetition in any row, comma, in any row, any column. Okay, there is no repetition. There is no repetition in any row, in any column. What is the what another property you can use? So this is the one property that you can use, that no repetition will happen in any row, any column. Another property you can use is that if A inverse is B, then what will happen? Then B inverse will also be A, right? If A inverse is B, then you can find B inverse equal to A. So these simple properties you can use. Okay, Kelly table of a group. So these simple properties you can use, and you can fill this Kelly table. Okay, first of all, and also another property that you can use is identity element. First find identity element, right? Okay, I can say row of identity element is equal to header. Row of identity element. Row of identity element is equal to same as the header. Okay, and I can say column of identity element. Column of identity element, that is same as vertical header. Okay, you can simply call it vertical or whatever, like you already understand what it means. Okay, so I can say that row of identity element will be same as header, and column of identity element, that will be same as the vertical header. Okay, so very simple. So these properties also you can use. First you tell me, in this table what this entry will be. Okay, what this entry will be. First you tell me what this entry will be. Remember, in any column no element can repeat. In any column, no element can repeat. So you cannot use A because A is already there. You cannot use B because B is already there. You cannot use C because C is already there. So we have to use D. There is no other way. Okay, this must be D. So this must be D. If this is D, then now you can find the identity element. So what is the identity element? So tell me, what is the identity element? That is A, because you can see the row of A is same as the header, and the column of A is same as the header, vertical header. Okay, so you can say identity element, that is E, and that is A. You got your identity element. Okay, now you tell me, can I put here? Can I put, for example, which two entries are missing? Here, tell me which two entries are missing here in this. Which two entries are missing? Remember, here you cannot use B because B is already in this row. In this row, no element can repeat. In this row, remember, in this row, no element can repeat. So you cannot use B comma A here because B is already here in this row, A is already in this row. So here in these two entries, you cannot use B comma A. So you have to use either C or D. Okay, now you tell me, here can I put D? Can I put D here? I cannot put D because in this column, no repetition should happen. Remember, if I put D, then here there is a repetition. So this repetition should not happen. So automatically I can say here will be C, here will be D. Very simple. Okay. Now you tell me, what about the remaining? What about these two? Here, which entries are missing? Here, which entries are missing? Already B comma A are there. So again, C comma D are missing. Again, C comma D are missing. Can I put D here? I cannot put D because already if I put D, then there will be repetition in this last row. In this last row, there will be repetition. So I cannot put D. So I can put C here. I can put D here. Now it is very simple. Already C, D, A are here. So automatically this entry will be B. Already D, C, A are here. So this entry will be B. So now we have the entire Kelly table. Okay, we have the entire Kelly table. Now you tell me the answer. Now you can easily find all the questions. What is the identity element? That is A. So I can say this statement is false. The question is asking for two statement. Okay, so this statement is definitely not true. Identity element. And what about abelian group? See, one thing you tell me, if it is a group of order 4, will you even check is this abelian group or not? If it is a group of order 4, then definitely it is abelian, right? I told you that. How many groups of order 4 are there? Tell me. How many groups of order 4 means how many templates are there? Groups of order 4. There are only 2 templates. Remember, there are only 2 templates, or I can say groups of order 4, only 2 templates. there are only two templates. Okay, or I can say that two non-isomorphic groups are there. Two templates are there, or I can say only two non-isomorphic group. Only two non-isomorphic group. Only two non-isomorphic groups are there. You already know, and both of them are abelian. Both are abelian. There are two templates, and both are abelian. What is one template? What is template number one? What is template number one? In template number one, you can notice that every element is inverse of itself. There are four elements, okay, and every element is inverse of itself. Every element is inverse of itself. This is one of the template. And what is the another template? This is one template of group of order 4. What is another template? The another template is like this, that here in the another template, you have identity element. Two elements are inverse of each other. Two elements are inverse of each other. And one element is inverse of itself. So these are the two templates, and both these templates are abelian. Okay, so there are two templates, and both these templates are abelian. And one of them is cyclic, one of them is not cyclic. Yes or no? Which template is cyclic? Which template? This template one is not cyclic. This template one, this is not cyclic. Remember, template one, this is not a cyclic. This is not cyclic. But template 2 is cyclic. And what are the generators in template 2? In template 2, what are the generators? What are the generators? What are the generators? So the generators are these elements which are inverse of each other. These elements which are inverse of each other. Okay. So very simple. These are the generators. Generators are A, B. So this one thing, let me tell you, groups of order 4 are very important. Do you agree with me? Because in the GATE exam, they will not give you group of order 6, group of order 8, because that will be very complicated. Okay. So most of the time, if you see, they will give you group of order 4. They will give you Kelly table of 4 elements. Okay. So that is the reason I can say that this is very important. So you should have everything on your fingertips. Yes or no? Groups of order 4 are very important. So you should have these on your fingertips. Okay, so there are two templates, two non-isomorphic groups are there. Only two templates are possible, and both of them are abelian. One of them is not cyclic, another is cyclic. Very simple. Okay, so here you can see. Okay, now you tell me here, which is this template? This group is which template? This group G, this is which template? Which template this group is? This is your template number 1, means this is a non-cyclic template, right? This is a not cyclic. This is your template number 1, and this is not cyclic. There is no generator in this G. In this G, you can see that there is no generator. There is no generator. You can check every element is inverse of itself. In this G, you can easily notice that every element of inverse is inverse of itself. A inverse is equal to A. What is B inverse? B inverse is equal to B. B inverse is equal to B. You can see what is C inverse? C inverse is equal to C. And what is D inverse? You can see D inverse is equal to D. So every element is inverse of itself. So that is the point. There is no generator. So this is not a cyclic group. What about abelian? Yes, it is abelian group. And what is the order of any element? In this group, order of any element, that is 2. Because every element is inverse of itself. Every element is inverse of itself. So order of identity element is 1. Other than that, every element has order 2, right? Okay, so you can easily notice that order of identity element will be 1. Other than that, order of every other element is 2. So this is also not correct. The answer will be what? Answer will be option C. Okay, so this will be the answer. Very simple. So this, remember, I can say group of order 4, you should have on your fingertips. Now let's move on. Let's see this question. So this is your question number 4. Let's solve it. So G is a finite group with 60 elements. What is the size of largest possible proper subgroup of G? So tell me, what is the size of largest possible proper subgroup of G? Proper subgroup means other than G. Proper subgroup means other than G. Other than G itself. Other than G itself. So proper subgroup means other than G itself. You cannot include G. Okay. Remember, G is a finite group with 60 elements. So this G, this is a finite group. This has finite number of elements. And we are saying that order of G, that is equal to 60. So if if you see, whatever subgroup is there, if H is subgroup, if H is a subgroup of G, then what will happen? Lagrange theorem says that if H is subgroup, this is the symbol for subgroup. This is the symbol for subgroup. If H is subgroup of G, then definitely order of H will divide order of G. Order of H will divide order of G. Okay. So very simple. This is your Lagrange theorem. This theorem we already know. Very popular theorem that this will happen. This is your Lagrange theorem. So after this Lagrange theorem, now you tell me. So here you can easily see the question is asking the largest possible proper, the size of largest possible proper subgroup. The answer will be 60. Answer will be 30 because the question is asking proper. The question is asking other than G. Proper subgroup means other than G. So you can see 30 divided 60. This is the largest value which will divide 60. This is the largest value other than 60 which will divide 60. 30 divided 60. Okay, and the question is asking for a proper. So that is the reason answer will be 30. In this same question, if I remove the proper word, in this same question, if I remove this proper word, now the answer will be 60 because 60 divides 60. So this is your Lagrange theorem, very simple. Now let's move on. Let's solve this question. So again, a group is given to you. Again, can you notice this is a group of order 4? Okay, so this is a group of order 4. Now this group is given to you. Kelly table is given to you. Which of the following is or are true? First of all, you tell me this is a group of order 4. Which template it is? Which template it is? I told you that there are two groups of order 4. There are only two templates. Group of order 4. There are only two templates. Only two non-isomorphic groups are there. Only two templates are there. Okay, so there are only two templates. Which template is this? You can easily notice that every element is inverse of itself. Every element is inverse of itself. So this is the template. Here the template is this, that every element is inverse of itself. This is the template E, A, B, C, where every element is inverse of itself. For all x, x inverse is equal to x. Okay, this is the template. Now, this template, okay, anyway, so in this template, the question is asking, G has exactly one subgroup of one element. How many subgroups of one element are there? How many subgroups of one element are there? Tell me. How many subgroups? I want to create subgroup of one element. I want to create subgroup of one element. Then if I want to create subgroup of one element, then can I create this? Can I create this A? Can I create this subgroup? What is the problem with this? What is the problem with this? If I create this subgroup, then what is the problem with this? Tell me. Remember the definition of subgroup. What is that? When can you say that H is subgroup of G? When can you say if you have a group G, if you have a group G, comma, hash, if you have a group G, then when can you say that H is subgroup of G, H, comma, hash is a subgroup of G? When can you say? Is subgroup of G. Okay, the operation should not change. The operation should not change. Okay, so you can see here also has, here also has. The operation should not change. So when can I say that this is subgroup of G if and only if, first of all, H must be a subset of G. Second, H must be a group. Second, H must be a group. H must be a group. Okay, only these two requirements are there. Only these two requirements are there. H must be subset of G and H must be a group. So if I create this A, comma, so what is the problem here? This is subset of G, right? Agree? This is subset of G, but this is not a group. Why this is not a group? Because this is not even closed. See, this is not even closed. This is not even closed. Why this is not closed? Tell me. What is the reason this is not closed? Because you can see A star A, that is equal to E, and that does not belong to here. That does not belong here. So you can see A star A star A, that is equal to E, that is equal to E. So you can easily notice that, and this A, this E does not belong to, this E does not belong to H. So very simple. So this is not even closed. Because this is not even closed, this is not even a group. So how many subgroups of element one you can create? Only one subgroup you can create. This is the only subgroup you can create. Okay, remember, this is the only subgroup of one element you can create. So G has exactly one subgroup of one element, that is correct. And this is true for every group, right? Agree? This is true for every group. For all groups, this is true. For all groups, whatever group you take, for all groups, whatever group you take, what will happen? For every group, what will happen? There is exactly one subgroup. There is exactly one subgroup of one element. There is exactly one subgroup of one element, and that will be your cute group. This cute group, identity element. Okay, this cute group, trivial subgroup. So this is called a trivial subgroup. Okay, so remember, for every group you can say, whatever group you take, for every group there is exactly one subgroup of one element. This is the only, nothing else. Okay, what about the next? What can you say about the next? How many? First of all, you tell me, how many subgroups of three elements? How many subgroups of three elements? Tell me about this one. Like, what about this? How many subgroups of three elements? The answer will be 0. Because remember, please understand that if H is subgroup of G, if H is subgroup of G, then definitely what will happen? Then order of H will divide order of G. Will divide order of G. So you can notice, if you have a subgroup of three element, if you have a subgroup of three element, but then 3 should divide 4, but 3 does not divide 4. 3 does not divide 4. So there is no such group. There is no such group. So there is no such subgroup. We have no such subgroup, because if you have this type of subgroup, then I can say order of this subgroup means 3 must divide 4, but 3 does not divide 4. So you can easily notice that this type of subgroup is not there. Or I can say number of subgroup of 3 element will be 0. Number of subgroup of 3 element, that will be 0. So I can say this is not correct. What about the next one? How many subgroups of 2 elements you can create? How many subgroups of 2 elements you can create? Subgroups of 2 elements. Very simple. First of all, remember, when you are creating the subgroup, first you take the identity element. That is mandatory. Whenever you are creating the subgroup, then first you take the identity element. This we have already seen, that if you have a group, see, if you have a group G, star, if you have a group, then how to create subgroup? Then how to create subgroup H of G? So how to create subgroup? First you take the identity element. Okay, this is the first thing. Take the identity element. Take identity element. Okay, so this is the first thing. Take identity element means this must definitely belong to H. This is the first thing. Okay, take identity element. This is the first thing. Okay, first you take the identity element. Very simple. Now, the second thing you will check, will you check associative property? Will you check associative property? There is no need, because it is already, star is already associative. Remember, there is no need because star is already associative. Okay, so it will remain associative. So you don't have to check associative property. The next thing you have to check is closure property. The next thing you have to check for closure property. And the next thing you have to check for inverse property. The next thing you have to check for inverse property. Only these properties you need to check. Okay, remember, star is already associative. So definitely you don't have to check associative property because it is a group. So star is associative. Star will remain associative. Okay, so very simple. Now here, so you want to create subgroup of 2 elements. So one element is fixed. That is identity element. No one can stop. Okay, this identity element will definitely be there. Now you have to choose which other element you need to take. Now you have to choose which other element you can take. So can I take A? Can I take A? You can check that. You can easily notice that, yes, this will be a group. This is closed. This is closed. First of all, you can check this is closed. You can check this is closed. Second, you can check identity element is already there. Third, you can check that A inverse is equal to A. So everything is there. Okay, so you can say, yes, this is a subgroup. Correct? Yes, this is a subgroup. Okay, very simple. Similarly, you can see E, B. This also will be a subgroup. This also will be a subgroup. You can check this is closed. You can check this is closed. And you can check B inverse is equal to B. So this is also there. Okay, similarly, what you can create? Similarly, you can create E, C. Again, you can notice this will be closed. You can easily notice this is closed. And you can notice C inverse is equal to C. And there is identity element. You have already taken the identity element. Okay, so very simple. So I can say there are 3 subgroups of order 2. There are 3 subgroups of 2 elements. This is correct. There are 3 subgroups of 2 elements. What about How many subgroups of order 4 element? Means order 4. How many subgroups of 4 elements? Only one, that is G. That is G itself. That is G itself. That is G itself. So which option is true? This is correct. This is correct. Answer will be ABC. The question is asking for true statement. Remember, the question is asking for true statement. So the answer will be ABC. Okay, one thing you tell me, one interesting thing I want to ask. This template, see, this is a order of 4 group. This is a 4 group order. Order 4 group. So here, this is the template. In the other 4 group, order 4 group template, what will happen? See, you notice that what is template 2? What is template 2 of order 4 group? What is that? What is template 2 of order 4 group? This is the template 2, that there is identity element. 2 elements are inverse of each other and 1 element is inverse of itself. So you have identity element. 2 elements are inverse of each other and 1 element is inverse of itself. Now you tell me one thing. Okay, what will change? For this template, what will change? For this template, what is going to change? See, in this template also, one subgroup of order 1. Here also you have one subgroup of order 1, right? One subgroup of order 1. Okay, one subgroup of order 1. So here also one subgroup of order 1, that will be identity element itself. This will be the identity element itself. Okay, so this is correct. How many subgroups of order 2? How many subgroups of order 2? Here, how many subgroups of order 2 you can create? Tell me. How many subgroups of order 2? So you can easily notice that if you want to create subgroup of order 2, first you take the identity element. First you take the identity element. With identity element, can I take A? With identity element, can I take A? With identity element, can I take A? Can I take A? With this identity element, can I take A? First of all, you tell me, is this closed? Is this closed? Will it be closed? Will it be closed? Okay, you check it. See, this is your template 2. This is your template 2 of order 4. Of order 4 group. This is the template 2 of order 4 group. In this template, what happens? This is the template, or I can say you can create the Kelly table. You can create. It will be like EABC. EABC. Okay, in this template, EABC, EABC. In this template, what will happen? A inverse is B. Okay, A inverse is B. So this will be E. Okay, now automatically you can notice, you cannot put C here, so you have to put B here. You cannot put C here, you have to put B. So automatically C you have to put here. Now you can see AC is there. So now you cannot put B here, so you need to put D and so on. Next, you can notice here you cannot put E here, so E you have to put here. So very sorry, some mistake we have done. So here this is correct, right? Because A inverse is B. Okay, A inverse is B, B inverse is C. A inverse is B, B inverse is A inverse is B, B inverse is A. So this will be identity element and this will be identity element. Okay, so now this will be D. And now you can easily notice that what will be these elements. See, here you cannot put C, so you have to put D here, you have to put C here. Now this is very easy. This will be A and this will be E. Okay, so very simple. Now you tell me, here you can notice what is A square? What is A square? Means A star A. What is A star A? A square is basically C. So this is not even closed, right? See, first of all, I am saying this is not even closed. E comma A. This is not even closed. This is not even closed. Also, you can notice A inverse is not there. A inverse does not exist, right? See, A inverse is B, but that does not belong to this, but that does not belong to E comma A. Okay, so you can notice that this is not a subgroup. What about this one? E comma B. E comma B. Again, this is not a subgroup. Again, this is not closed. You can see what is B square. B square is C. So again, you can notice this is not closed. This is not closed. First of all, this is not closed. And second, you can notice that B inverse is equal to A. B inverse B inverse is equal to A. This B inverse is A, and that also does not belong. That also does not belong to the to this E comma B. Okay. So what about this one? E comma C. What about this one? Is this correct? Is this closed? What is C square? Let's check. What is C square? So C, that will be E. C square is E. Yes. So this is closed. Very good. So I can say this is closed. Okay. What about every other property is also satisfied? Inverse property is also satisfied, and identity element is here. So how many subgroups of order 2? Please tell me how many subgroups of order 2 for this template? Means for this template 2 of order 4 group. For this template of order 4 group, this is your template E, A, B, C, where A inverse B, B inverse A, and C inverse C. And this is identity element. So what is this? How many subgroups you can create? Subgroups of order 2. That will be equal to only one number of subgroups of order 2. So how many subgroups of order 2? Only one, and that will be E comma C. This is the only subgroup you can create. Okay, so anyway, now let's move on. Did you understand the analysis of this question? Please tell me. Did you understand the analysis of this question? That so this is your order 4 group, and we have done the analysis. How many subgroups you can create? Okay, very simple. Now let's move on. Let's see this question. This is very simple. Actually, you can do it very easily, because again, you have a group table. You have to complete this Kelly table. Okay. So this group table is given to you. Now, first you fill it. We have to fill it. First, you tell me one thing. What can be the identity element? Like, tell me. Can A be the identity element? Can A be the identity element? Let's find the identity element. Can A be the identity element? Is it possible? Why it is not possible? See, if A is the identity element, then this should be same as this. Then this row should be same as this header, but they are different. So A is not the identity element. What about B? If B is the identity element, then this row will be same as this header, but they are different. But again, they are different. So B is not the identity element. What about C? If C is the identity element, then this row will be same as this header, but they are different. But these two are different. So I can say that C is also not the identity element. What about D? D is possible, right? D is possible, but. See, can you put E here? No. In this column, no repetition. In this column, you cannot repeat. So E will not come here. I can say this is definitely not E. If this is not E, then can I say D is not identity element? See, if this is not E, then definitely this header is different from this row. This header and this row, they are different. Because they are different, so easily I can say D is also not the identity element. So what will be the identity element? Identity element will be E. Okay, so we have found the identity element. So very simple. Identity element we have found, that is your E. Now you tell me, what about the next? After finding the identity element, I can fill this. I can say that this will be A, this will be B, this will be C, this will be D. This will be A, this will be B, this will be C, this will be D. Okay, so this is what I can do. What is the next step? Now the next step. See, now the next step, you can fill this. Okay, which entries are missing in this second row? Which entries are missing? So in this second row, you can notice D comma C missing. But I cannot put C here because this repetition will happen. So I cannot put C here. So I can put C here. I can put D here. So second row is also there. Okay, we got second row. If we got second row, we can also see the third row. What will be the third row? In this third row, no repetition should happen. So only one element is missing. That element is A. So this element will be A. Very simple. Okay. Next, you can easily notice that this element will also be got, because in this row, in the fourth row, which element is missing? Only identity element is missing. So here I can say this will be identity element. What about the last row? Now you can fill. See, what about the second column? In the second column, which element is missing? Identity element is missing. In this third column, what is missing? A is missing. In this fourth column, what is missing? In this fourth column, you can see B is missing. In this last column, what is missing? In this last column, you can notice C is missing. So you got your Kelly table. Okay. Filling the Kelly table, that is very fun, right? Are you enjoying these type of questions where you have to fill the Kelly table? You have to fill the Kelly table. The partial Kelly table is given to you. You have to fill it. This is actually very interesting. Okay. This type of question has not come in the GATE exam. Let me tell you. Okay. Remember, this type of question where you have to fill the Kelly table, this type of question has not come in the GATE exam so far. But this is a very standard question. In every standard book, you will find this type of question. All these questions are taken from standard resources. So you can see one day this question will come. That guarantee I am giving you. Okay, one day, definitely one day this question will come. And when this will come, then I can say Go Classes students, definitely they will get benefit because we have done quite practice. Enough practice we have done for this type of questions. So it will not be a surprising question for you. Okay, we have done enough practice. Now let's move on. Now you tell me the remaining. What is D star B? Tell me quickly. What is D star B here? So you can see D star B, that will be A. So you can see D star B will be A. So this is correct. The question is asking for true statement. Question is asking for true statement. What is B star D? What is B star D? That is also A. That is also A. This is also correct. Okay. What is D D D D? What is that? What is D D D D? See, you can just find DD. Okay, you can just find DD. What is DD? DD is C. So now you can say, what is CC? Remember, DD is C. Now what is CC? CC, that is A. Okay, so that is A. So this is not correct. What about the last one? What about the last one? A, B, C, D. A, B, C, D. What you can do? Just see what is AB. Tell me what is AB? AB is C. AB is C. And what about CD? And what about CD? CD, that is B. Now what is CB? What is CB? That is E. So yeah, this is correct. So what is the answer? Answer will be ABD. So very simple question. Okay. Now let's move on. So this type of questions we have done. A lot of questions we have done. Okay. Can you do the complete analysis of this question? I give you this as a homework. Please comment on this question. You comment your complete analysis. Okay. Please comment your complete analysis on this question. Go to this question on the GATEOverflow website where this question is there. Go to the link of this question on the GATEOverflow website. You go to there and comment or answer. Either you can write a comment or you can write an answer. That is your choice. Okay, but please write your complete analysis. In the complete analysis, what are the things you can write? In the complete analysis, what are the things you can find? If you want to do the complete analysis, what are the things you can find in the complete analysis of previous group? So what are the things like you can some data? So you can find, for example, in the complete analysis, you can find inverse of each element. Okay, you can find inverse of each element. This is what you can find. You can find order of each element. You can find order of each element. You can find, is this cyclic or not? Is this cyclic or not? You can find, is this abelian or not? See, this is order 5 group. So can I say this is order 5 group? This is order 5 group. So can I say it will definitely be cyclic? It will definitely be cyclic because this is prime order. You already know that if you have a group of prime order, then that is definitely cyclic. That is definitely cyclic. Every cyclic group is abelian. Every cyclic group is abelian. So this is very easy. Okay. Group of prime order is cyclic and cyclic is abelian. All these things, anyway, these things. So more you can do. Okay. Maybe you can find some subgroups. Okay. You can find subgroups of G. First you tell me, because order is 5. So how many subgroups are there? Because order is already 5. Order is already 5. If you have a group of prime order, then how many subgroups are there? If you have a group of prime order, if you have a group of prime order P, then how many subgroups are there? Only 2 subgroups are there, right? group of prime order, only two subgroups are there. There are only two subgroups. There are only two subgroups. You don't even have to check. See, there are only two subgroups. What are those? Group of prime order will have only two subgroups. Will only have two subgroups. Why? What is the reason? Group of prime order has only two subgroups. What is the reason? Because no element will divide P, right? No element is going to divide P. Agree? The only element which will divide P is P, 1. Yes or no? Only element to divide P. You can notice if any element divides prime, if any number divides prime P, then that element is either 1 or that element is P. So that is the reason I am saying that if you have a group of prime order, only two subgroups are there. That will be G itself. That will be G itself. You have a group G, that will be G itself, and that will be your cute group. That will be your cute group. So only two subgroups are there. Okay, anyway, like this, you can do some analysis. You can, for this question, you can find order, you can find all these things, you can just find. Okay, one more thing, one more interesting thing. What can you say about order of any element if you have a group of prime order? If you have a group of prime order, what can you say about order of any element? If you have a group of prime order P, then what can you say about order of any element? Tell me, what is the order of identity element? See, order of identity element, where is the identity element? That will always be 1. Okay, that will always be 1. But what is order of A? What is order of A? Where A is other than E, where A is not equal to E. So what is order of A? That will definitely be P. Why? Because order of any element will divide order of group. Agree? Order of any element, this we already know, Lagrange theorem. Lagrange theorem. In the Lagrange theorem, what happens? I told you that order of any element will divide order of group, right? So you can see that if you have a group G, then if A belongs to G, then what will happen? Order of A divides order of G. Very simple. Order of any element will divide order of group. So from here, you tell me, order of any element will divide order of group. So now you tell me, what is the order of A? The only number which will divide P is 1, P. Agree? The only number which will divide P is 1, P. Only number to divide P. Only number which divides P. Are 1, P. Okay, so that is the reason I can say order of identity element will be 1. Order of all other element will be P. I told you to do the complete analysis, but I have done it. Okay, this is interesting, right? The group of prime order, a lot of things are fixed. Agree or not? Group of prime order, these are interesting. These are important. Group of prime order, a lot of things are already fixed. Group of prime order P. Okay, these are important. Because a lot of things are very simple for there. These are important, remember. Why these are important? Because a lot of things are already fixed. Okay, a lot of concepts are already fixed for these groups. So these are important, and we have already done the analysis in our class. So anyway, so very simple. I told you to do the complete analysis, but I have already done it. So let's move on. Now, let's see this. This is very interesting question. Question number 9. In this weekly quiz, one of the very interesting questions. Okay, and let me tell you, this type of questions have come in the GATE exam already. And this question is taken from a university. This is from Berkeley University. You can notice this question. I have taken this question number 6. This question I have taken from Berkeley University. So all the questions that you are solving in Go classes weekly quizzes in the test series, all the questions that you are solving, okay, you can tell yourself that you are solving from standard universities. Okay, you are solving from Berkeley, Stanford, NPTEL, IIT, okay, standard books, so MIT. So all the questions that you are solving, these are from standard universities. So anyway, let's see this. This is very interesting question. So from Berkeley University, I've taken this. Now let's move on. Now let's see this question. This is quite interesting. But before we see this question, I want to ask you, do you remember I told you in our lectures, I told you, if you have a group, let's assume you have a group G comma star. Okay, let's assume this is your group. You tell me one thing. I told you that if A star B is equal to E, if this happens, what can you say about A? If this happens, then what will happen? If this happens, then what will happen means, if A star B is equal to E, then tell me what this B is behaving as. If A star B is equal to E, then what this B is behaving as? This is behaving as inverse of A. Then A inverse is equal to B, or I can say B inverse is equal to A. Then A inverse is equal to B, B inverse is equal to A. And this direction is also correct. These two directions, this we have already seen in our lectures. And the proof is also very simple. See, proof is also very simple. You have a group. What is the proof? If A star B is equal to identity element, if that is equal to identity element, then what is the proof? Then you can notice, you can multiply with A inverse on the LHS. If then what you can do from here, you can multiply with A inverse on LHS. You can multiply with A inverse. Let's multiply with A inverse on LHS. So that will be like A inverse, because A inverse star E, that will be already A inverse. That will be A inverse. And this will be E. This will be E. And EB will be EB will be B. So from here you got B equal to A inverse. Very simple. Agree? So this is a simple proof. Now I told you this is very important. If whenever you see this, what should come to your mind? Please understand. Whenever, this is a suggestion. This is my suggestion to you. This is my suggestion to you, that whenever you see this type of equation, what should come to your mind? In a group, if you see this type of equation where you have identity element here, if you see this type of equation where you have identity element here, and here you can have anything, for example, you can have X star Y, then tell me what should come to your mind where you have identity element here, If this equation, this type of equation you see, whenever you see this type of equation, immediately you should think that X inverse is equal to Y, Y inverse is equal to X. Okay, this is a strong suggestion. So very simple, because see, if this E is on the RHS, or I can say basically if this is equal to E, this is equal to identity element, then definitely the question is asking something about on this. Okay, this is my experience from the group theory questions. In any question, whenever I have seen this equation, whenever I see this equation, immediately this comes to my mind. Okay, so for example, let's do some practice of this. For example, if you see this, let me tell you, if you see ABCD is equal to E, this is my question. You have a group. You have a group G. Okay, this G comma star, this group you have. And now you tell me, if you see this equation, then what will you do? What are the things you can get from this? Let's assume E is the identity element. Let's assume this is the identity element. Okay, then what you can find from here? Then tell me, what is the A inverse? What is AB inverse? What is CD inverse? What is BCD inverse? All the things. For example, what is ABC inverse? All the things. So now you can easily notice. See, first of all, when you have this equation, this is your, before I tell me here what this ABCD actually means. The operation is star. Then what it actually means, I told you what it actually means. The operation is star. This actually means what? This actually means A star, B star, C star, D, right? But this is how we write. This is just for convenience. We write this for, this is just a short notation. This is just a short notation for A star, B star, C star, D. Okay, because remember your operation is star. So actually this means A star, B star, C star, D. Anyway, now let's see this. So here you can easily notice that because A, B, C, D, you can think like this. A, B, C, D is equal to E. So from here, what will be A inverse? From here, A inverse will be, I can say BCD, or I can say BCD inverse is A. BCD inverse is A. What is another thing you can do? You can think like this. Agree? Because group is associative. Remember why I can do these type of things? I can, this ABCD, I can think like this. I can think like this. Why? Because group is associative. Because group is associative. Because this group is always associative. So that is the reason I am thinking like this. From here, what you can say? You can say that AB inverse is equal to CD. You can say CD inverse is equal to AB. Okay. What else you can do? See, ABC, I can think like this. Agree? I can think like this. From here, what I can say? I can say D inverse is equal to ABC. I can say ABC inverse is D. So very simple. Okay. I hope this point is clear. So this is the final point, that in a group, whenever you see this, in a group, you have a group, and in this group, if you see this, that X, Y is equal to identity element. Okay. This, if you see, then it will mean that X inverse is equal to Y, Y inverse is equal to X. And this is two-way. This is two-way. Okay. Now let's see this. Now this question is actually very easy. Now there is nothing in this question. So here, G is a group that is already given to you. Identity element is G, that is given to you. A, B, C, these are the elements of G, that is given to you. Okay. This property is given to you. This property is given to you. And then the question is asking something about ABC, ABC, ABC. Okay. Something about ABC, ABC, some question is asking. So this property is given to you. What will come to your mind? A star B star C, that is equal to identity element. So what you can say from here? What you can say from here? You can say that I can say C inverse will be equal to what? C inverse will be A star B, right? This is the one thing you got. Okay, this is the one thing you got. But remember one thing, from associative property, what I can say? Using associative property, what I can say? I can say that A star B star C, that is also E. Using associative property, correct? Using associative property, associativity. Using associativity, what I can say? I can say that A star B star C. Using associativity, I can say A star B star C, that is equal to E. So the second thing I got A inverse. What is A inverse? That is B star C. That is B star C. This is A inverse. So like this you can do. I hope all these points are clear. So you got C inverse, you got A inverse. Now you tell me. Now let's see. You got A inverse, you got C inverse. So if A inverse is B star C, then what can you say about, if this is the point, then what can you say about A star B star C? That will be E. From associativity you can see. Okay. So that will be E. Because you already know that, this point you already know that if X inverse is equal to Y, then definitely XY will be equal to E. This point you already know. In group. In a group, this point you already know. So here you can easily notice that the statement one is true. Actually, statement one you can easily see from associativity also, right? Agree? From associativity also you can check the associativity. Just apply the associative property. Just apply the associative property. You can see option A you will get. Just apply the associative property. Because group is associative. So just apply the associative property. So you will get this. Okay, option A you will get. Now what about option B? How will you get option B? Can you get option B using associative property? Can you get option B using associative property? No, you cannot get using associative property, right? Using associative property, you cannot get option B. But what you can do? You can just apply this. We already know A inverse is B star C. We already know that A inverse is B star C. We already know this. So now you can call it D. Let's call it, or maybe you can call it X. So A inverse is X. What that means? A inverse is X. What that means? That means AX is equal to E. That means AX is equal to E. Okay. And that means X is B star C. X is B star C. Or I can say, see, AX is equal to E. I can also say XA equal to E. I can also say XA equal to E. xa equal to E. If xa equal to E, then I can say what is x? X is B star C star A is equal to E. This is your option B. This is your option B. See, we are using the inverse property. We are using the inverse property. Using the inverse property, or we got option B. Did I use commutative property? Did I use commutative property? Tell me. Did I use commutative property? I did not use commutative property. Can I use commutative property? Can I use commutative property? I cannot use commutative property because group may or may not be commutative. Group may or may not be commutative. So remember, I am not using the commutative property. I am simply saying A inverse is equal to B star C. If A inverse is X, then XA will be equal to E by the definition of inverse. Okay, so easily you can see I got option B. I got option B. If I got option B, then using associative property, I can get option D. If I got option B, then using associative property, I can get using associativity, I can get option D, right? Correct? Using associativity, I got option B. Remember, very simple. I am telling you that I got option B, that B star C star A is equal to E. Now using associativity, this is your option B. So using associative, just apply the associative property. Apply the associative property. So you will get B star C star A equal to E. Okay, one more interesting thing. Even the question is not asking. But what can you say about B inverse? See, this is your option D. The question is not asking, but what is B inverse? You can easily notice B inverse is C star A. B inverse is C star A. So we got A inverse also, B inverse also, C inverse also. A inverse, B inverse, C inverse. All of them we got. Okay. What about this one? What about this next one? See, C inverse you already know. You already know what is C inverse. See, already you know C inverse. Then tell me what will be. If you know C inverse, then what will be C star A star B? What will be that? Remember, C inverse is A star B. C inverse is A star B. Okay, C inverse is A star B. Let's call it Y. C inverse is Y. Then in this situation, what will be CY? CY will be E. CY will be E. So that means CY, that will be E. So very simple. So you got, this is your option B. This is option C. This is your option C. So you got option C also. So all of them you got. Tell me, did you find this question interesting? See, with only one equation, you can do a lot of things. With only one equation, a lot of things you can do. Only one equation is given to you, but using that equation, you can find A inverse, you can find B inverse, you can find C inverse, and you can create these type of equations. From this equation, you can create these type of equations. Simple. Okay. This is the beauty of standard questions. I told you this question is taken from Berkeley University. Okay. So this is the beauty of standard questions. Actually, let me tell you, in this question, only one thing he is asking. In this Berkeley question, he is only asking one option, but I have created some more. I have created 4 options. Of course, you can create 4 options, 8 options. You can create as many as possible. That is your choice. Okay. Very simple. Logic is important. So this is what we do actually. Let me tell you, whenever we find any question in the standard university, some question we find, some gate relevant standard question we find, then we convert this question into a objective question. Okay, so this conversion we have to do. For example, I have to think that, okay, the question is asking only this. The question is asking show that this will happen, but I created some more options that you can do. Okay, very simple. So this is an interesting question. I hope you understood. Anyone has any doubt? Please tell me. In this question, do you have any doubt? Let me know. Did you understand the analysis of this question? Please tell me. Simple. Now let's move on. Okay, so this question we have already done. The complete analysis we have seen. Okay, let's see this. I think this is very easy question. You can just do it. The following is Kelly table of a group. A Kelly table of group is given to you. The order of 4 star 4. What is 4 star 4 in this Kelly table? What is 4 star 4? See, first of all, 4 star 4. This is 4, this is 4. 4 star 4 is 3. This is your 4 star 4. So first of all, 4 star 4 is equal to 3. So the question is asking what is order of 3? The question is asking what is order of 3? Okay, so tell me what is the order of 3? If you want to find order of 3, then what is 3 power 1? That will be 3. First of all, you find identity element. Sorry. First of all, you find identity element. What is the identity element here? You can check what is the identity element in this question. Please tell me. What is the identity element? Yeah, interesting thing is identity element is 5. Okay, please understand. Can I say in any group, if you see some group, will you always think that identity element is E? Okay, this is, see, if you see any group, this type of group, if you see, then will you blindly assume that E is the identity element? Will you blindly assume E is the identity element? No. Okay, E may or may not be identity element. Similarly, will you blindly assume that 1 is the identity element? Will you blindly assume that 1 is the identity element? No. Okay, here if you notice, actually the identity element is 5, because you can easily notice, you can easily see here that this row is same as this header. This row is same as this header. So they are actually same. Similarly, you can see this column is same as this. Similarly, these two are same. So here, if you notice the identity element is actually 5. 5 is the identity element. Okay, remember in this question, 5 is the identity element. So please don't blindly assume that 1 is the identity element. This will happen. Some students will blindly assume that 1 is the identity element. Some students will blindly assume that E is the identity element. Okay, that is the reason. Very simple. Now you tell me, you know the identity element is 5. So what you are looking for? 3 power 1 is 1. 3 power 1 is 3. That is not equal to identity element. Identity element is 5. So what is 3 power 2? What is 3 power 2? Tell me. What is 3 power 2? Let me know. 3 power 2. 3 power 2 is 1. 3 power 2 is 1. Did I get identity element? Is this identity element? No, this is also not identity element. Remember, identity element is 5. Some students will answer 2. Are you getting? Because some students will say, okay, yeah, I got 1. I got identity element. I got 1. So some students will say that order of 3 is 2. That is the trap, I can say. Okay, so anyway, remember, this is not the identity element. What about 3 power 3? 3 power 3 means 3 power 2 into 3. Okay, that means what is 3 power 2? 3 power 2 is already 1. What is 1 star 3? What is 1 star 3? That is 4. Did you get identity element? No, this is not identity element. Identity element is 5. Okay, what about 3 star 4? Say 3 star 4, you can do like this. 3 power 2, 3 power 2. Okay, what is 3 power 2? That is 1. So that will be like 1 star 1. That will be like 1 star 1. Because 3 power 2, that is equal to 1. 3 power 2 is equal to 1. So what is 1 star 1? 1 star 1, that will be 2. Okay, that will be 2. Okay, next, what about 3 power 5? 3 power 5, you can do like this. For example, you can say 3 power 4 into 3. Okay, what is 3 power 4? That you already know, that is 2. That is 2. So I can say that 2 star 3. What is 2 star 3? In this question, 2 star 3, that will be 5. Yeah, 2 star 3, that will be 5. And yes, that is the identity element. So order of 3 will be 5, right? So here I can say this will be the order. Order of 3 will be 5. So remember, order of 3, that will be 5. So very simple, you can do. The question is asking order of what that will be. Answer will be 5. Okay, so can I say 3 has generated how many elements? If order of 3 is 5, then how many elements 3 has generated? If order of 3, if that is equal to 5, then how many elements 3 has generated? It simply means 3 generated 5 elements. It simply means 3 has generated, this 3 generated 5 elements. This 3 has generated total 5 elements. So in the group, you have only 5 elements. So 3 has generated the entire group. Okay, group has 5 elements. Group has 5 elements only. Only 5 elements are there. So it means 3 has generated the entire group. 3 has generated entire group. 3 is generated entire group. If 3 generated entire group, then 3 is the generator. Then 3 is the generator. Then 3 is the generator. If 3 is the generator, so this is a cyclic group. So this is a cyclic group. Yes or no? 3 is the generator. So that is the reason, because you have a generator. This generator you got at least one generator. I can say 3 is a generator. Because you got 3 generator, so it simply means this G is cyclic. This G is a cyclic group. Okay, very simple. Now, very simple. You can do like this. Okay, so a lot of analysis we have done in our lectures. You can do a lot of analysis in this question also. Agree? This is what we have done in our lectures also. We have done the complete analysis to different concepts we have linked. Okay, in our group theory course. All the concepts, did you notice all the concepts? They are linking to each other. What is the order of an element? What is subgroup generated by element? What is the connection between subgroup generated by element and order of that element? Okay, so all these things are linking with each other. This group theory is very interesting subject. I can tell you that. If you are understanding, are you finding group theory interesting? Like, this is not a boring subject. This is very interesting. A lot of interesting questions can be created. Okay, so if you study this, I can say from the Go Classes course, if you study the entire group theory course, all the lectures, if you watch, then definitely you will find this very interesting. Okay, let's move on. So this question we have done. Now let's see this question. Let's solve this. This is also another very interesting question. Okay, so before we solve this question, I want to ask you something. I want to ask you this question. Please tell me the answer. Please tell me the answer. You have a group G. I am talking about a group. Okay. If A power n is equal to identity element, then what can you say about order of A? If A power n is identity element, then can I say n is the order? Then can I say n is the order of? Can I say n is the order of A? No. Then the answer will be what? Yes, order of A will be less than equal to n. This will be the answer. Answer will be option D. Because remember, what is the order of A? What is the definition of order of A? If you have a group, then what is the definition of order of A? Remember, order of A is the smallest. This word, please don't forget about this word. This smallest word you don't forget. Okay, this smallest word you don't forget. Smallest positive integer. Smallest positive integer. This positive word also you don't forget. Positive means greater than 0. Positive means greater than 0. Or I can say greater than or equal to 1. Greater than or equal to 1. So I can say smallest positive integer n such that A power n is equal to E. So remember, if I say that A power n is E, if I say A power n is E, it simply means this n may or may not be smallest. Agree? Here, this n may or may not be smallest. This n may or may not be smallest. This n may or may not be smallest. May not be smallest. This n may or may not be smallest. So I can simply say that order of A, that will be less than equal to n. That will not be greater than equal to n. That will be less than equal to n. So this will happen. Okay. Now, one more thing I want to ask you. If you want to prove that order of A is equal to order of B, then what you need to do? Please tell me a question I am asking. What you will do if you have a group? And in this group, if you want to say that you have two elements, let's assume you have two elements x, y. If you want to prove that order of x is equal to order of y, what you need to do? To prove order of x is equal to order of y, what we need to do? What we need to do? What we need to do? Please tell me. What we need to do? If you want to prove that order of x is equal to order of y, what you need to do? See, very simple. Can I do this? Will it be enough? Like, I am asking, will it be enough? You have a group, and x, y belongs to this group. You have a group G. Okay, I'm asking, please tell me. If you want to prove that they have same order, will it be enough? Will it be enough? So if x power n is equal to identity element, okay, if x power n is equal to identity element, then y power n is also identity element. If I prove this, will it be enough? If I show this, will it be enough? If I show this, will it be enough? This will not be enough, right? This will not be enough. Okay, this will not be enough. I hope this point you are getting. See, if I show this, showing this is not enough. Showing this is not enough. Because which factor we are missing? Which factor we are missing? We are missing the smallest factor. Okay, this factor, the smallest factor we are missing. The smallest factor we are missing. Okay, please understand. So what do you need to do then? What do you need to do then? If they have the same order, then something beautiful will happen. See, if they have the same order, then I can show this. I can show that this will happen, then this will happen, and this will happen, then this will happen, right? Now this is enough. Now this is correct. We need to show this. Showing this is enough. Agree or not? Yes or no? Showing this is enough. Means if this will happen, then this will happen. If this will happen, then this will happen. Okay, are you getting this point? Okay, so this is what we can show. Means whenever x power n will be equal to e, then y power n is also e. And whenever y power n is e, then x power n is also e. So this is what we can do. This is what I'm saying. So please understand, if you want to prove that order of x is equal to order of y, then what you will do? Simple method. Just do this. If x power n is equal to e, then what you need to show? Tell me. Then show y power n is equal to e. And if y power n is e, then show what? Then show x power n is e. Isn't it simple? Please tell me, isn't it simple? If you want to prove that two elements have same order, they have same order. If you want to prove two elements of same order, then just prove that if x power n is e, then y power n is also e. If y power n is e, then x power n is also e. Means whenever this x is becoming e, whenever this is becoming e, this is also becoming e. And whenever this is becoming e, this is also becoming e. So their order will be same. Agree? Is this point clear? Very simple. So now let's solve this question. Now we can solve this question very easily. Now this is a straightforward question. So let's solve. First of all, let's solve this part. Actually, the first part is very simple. The first part is by definition. See, the first part is actually very simple. There is nothing in this first part. So let me tell you the first part first. So let's do this. What is the definition? If x inverse is y, then what can you say? If x inverse is y, then what you can say? You can say xy is equal to e, right? Agree? So just apply that. If x inverse is y, then xy is equal to e. So here, just apply that. If you apply that, then what you are going to get? You will get that BAC is equal to A inverse. So what can I say about ABAC? What can I say about that? Please tell me. ABAC. What can I say about ABAC? Remember, BAC is equal to A inverse. BAC is equal to A inverse. So from here, I can say that A, BAC, that will be identity element. Okay, that will be identity element. Now this is your favorite. I told you this equation. Do you remember? I told you that whenever you see this equation, what should come to your mind? Whenever you see this equation, that something is equal to E, whenever you see this equation, then I can say that basically ABAC is equal to E. Okay. And from here, I can say, what is AB inverse? From here, what is AB? What is AB? AB is equal to AC inverse. Agree? I can say, what is AB? AB is equal to AC inverse. So now the question is asking CAB. The question is asking, what is CAB? What is that? Okay, the question is asking. So tell me, what is AB first? The question is asking, What is CAB inverse? Okay, so what you do, CAB inverse, the question is asking. So first you tell me, what is ACAB? Let's find out. Let's find out what is ACAB, because the question is asking, is CAB inverse? This is what the question, see, the question is asking, is this happen? Question is asking, is CAB is equal to A inverse? This is what the question is asking. So if you want to show this, then what you can show? If you want to show this, then what you can show? You can show that ACAB is equal to E. Agree? You can show that ACAB is equal to E. So let's prove what is ACAB. So let's show what is ACAB. Let's find what is ACAB. So ACAB means, you already know that AC is equal to AB is equal to AC inverse. This you already know. AB is equal to AC inverse. We already know that. We know AC inverse is equal to AB. If AC inverse is AB, then automatically what will happen? If AC inverse is AB, then automatically that will be equal to E. And this is what we wanted to prove. So from here I can say that A inverse will be CAB. A inverse will be CAB. Please tell me, isn't it simple? I'm asking simple question. Isn't it simple? Like, oh, we are only using this thing. We are only using this fact that if XY equal to E, then X will be Y inverse. And if X is Y inverse, then this will happen. We are only using this thing. This fact we are using. And did you notice on this fact, on this simple fact, we have solved 2-3 questions we have done, right? On this simple thing, we have solved 2-3 questions. So very simple. If XY equal to E, then X will be Y inverse. And if X is equal to Y inverse, then XY equal to E. So we are just using it. See, please understand that question is saying BAC equal to A inverse, that is given to you. BAC is equal to A inverse. This is given to you. So from here I can say ABAC is equal to E. ABAC, that is equal to E, means ABAC is equal to E. And if ABAC is equal to E, that means AB is equal to AC inverse. AB is equal to, from here I can say AB is equal to AC inverse. And then you can simply say, the question is asking is CAB equal to A inverse? That simply means, this means ACAB equal to E. So this is what we need to prove. So what you can do, very simple. You know AC is equal to AB inverse. So you can use this fact. And then you can get this. You can prove it. And once you prove it, then A inverse will be CAB. Once you prove it, then A inverse will be CAB. Okay. So very simple. This is your part 1. Now let's see the part 2. What is the part 2? The elements BAB and ABB have the same order. This is interesting. Can you take your copy pen? So tell me what you need to prove. What you need to do if you want to prove, to show order of X is equal to order of Y. What you need to do? Order of X is equal to order of Y. What you need to do? To show what you need to do? Very simple. You need to prove that if X power n is E, then Y power n is also E. If Y power n is E, then X power n is also E. This is what you need to do. That's it. This is what you need to do. So let's do it. So the question is asking BAB and ABB. Basically here X is a BAB, and Y is ABB. Okay, so let's do this. So first of all, you tell me, we will do this. If BAB power n is E, then what we will prove? Then what we need to prove? Then can I say, then find what is ABB power n. Then find what is ABB power n. Okay, means if this happens, if BAB power n is equal to E, then find what will happen to ABB power n. So this is quite simple. You can see, if BAB power n is equal to E, let's open it. So what we will get? We will get BAB BAB, 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 how many times? N times BAB, that is equal to E. Like for example, if it is 5 times, like for example, let's assume it is I'm writing this 5 times. If I write this 5 times, let's assume. Now, can you notice this same thing? Can I write like this, that ABB, you are getting ABB in the between, right? Yes or no? If you notice, you are basically getting ABB in between. Agree? Here, BAB, 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 that is equal to E. But you are getting in between, you are getting ABB. This ABB you are getting. Again, this ABB you are getting. Again, this ABB you are getting. Again, this ABB you are getting. So how many ABB you got? So you got ABB power 4 AB. Okay. Right. This is given to you. This is given to you as, this is already given to you because we are just using, this is given to you as N. Okay. Now you tell me one more thing. One more thing that, so this is like N minus 1. So basically, this is what I'm suggesting. I'm suggesting that this is what I'm suggesting. I'm suggesting that if this happens, then what you will get from here, what you can get from here, you will get this something like this B, and then ABB power N minus 1, and then you will get AB. This is equal to E. You are going to get this. This is equal to E. Okay, correct? Agree? See, this is simple, right? Is this simple? See, I'm writing, if this happens, if this is given to you, okay, if this is, if I'm assuming if this happens, then you can open it. Okay, if you open it 5 times, if you open this 5 times, then basically you are getting ABB, ABB. 4 times you are getting ABB. So if you open it N times, if you open this N times, then you will get ABB N minus 1 time. Okay, this is what you are getting. Now from here, what you can say, what is ABB power N minus 1? Now from here, what you can say about what you can say about ABB, what you can say about this, like for example, or I can say, what is this? Tell me from here, like from here, what is ABB power N minus 1 AB? What is that? That is equal to what? Tell me. Means from here, what is this? What this will be? This will be B inverse. This will be B inverse. Okay, you can think like this. You can think like this. You can think like this. So you got B inverse. Simple, right? Okay, now actually what we want to find, we want to find ABB power N minus 1, ABB power N. We actually want to find ABB power N. We actually want to find ABB power N. So we want to find what is ABB power N. That is equal to ABB power N minus 1 ABB. And this already we know. Okay, tell me what is this? ABB power N minus 1 AB. That is equal to B inverse. This is already B inverse. Okay, so if this is B inverse, then what you can say? B inverse B. That is equal to E. So isn't it interesting? The proof, did you understand? So what we have proven? So we have proven that if BAB power N is E, then ABB power N is also E. Please tell me, did you find this interesting? This proof. Simple proof, right? Just some manipulation. So this is what we have seen. Please tell me, did you understand? See what I'm saying. I'm again telling you. If you want to prove that X comma Y have same order, 2 elements have same order. If you want to prove that 2 elements have same order, then what you need to do, very simple. You need to prove that if this happens, if X power N is E, then Y power N is E. And if Y power N is E, then X power N is E. These 2 things you have to prove. Okay, you have to prove this and you have to prove this. So you have to prove these 2 things. You have to prove these 2 things. Okay, very simple. Now, what we are proving, what is the first thing we are proving? We are trying to, first we will prove. Tell me, first we are proving if BAB power N is E, then first we are proving, then prove that ABB power N is E. Okay, this is our task. This is our task. So for that we are doing. So it is already given that BAB power n is E. Okay, so I'm writing it, I'm opening it, open it, BAB, 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 BAB. If I open it 5 times, if I open it 5 times, then I will get ABB, ABB 4 times, right? In the between, in between, I will get ABB 4 times. So similarly, if I open it n times, this BAB, if I open it n times, then basically I will get it n minus 1 time. So this is what I will get. Please understand. Okay, if I open it 5 times, I will get ABB, 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 ABB. 4 times I will get. So I will get this equation. This equation I will get. So the same equation I will get, I can say n minus 1 time ABB I am getting. I am getting ABB n minus 1 time. So I am getting ABB n minus 1 time. Now from here you can see, basically what is this? From here you can see what is this? Okay, just focus on this. So if you focus on this means I can say B, this is already here. B ABB power n minus 1 AB is equal to E. So just focus on this. Focus on this. This will be equal to B inverse. This will be equal to this thing will be equal to B inverse. So that's it. Now you ask what is ABB power n, because we want to find what is ABB power n. What is ABB power n? So ABB power n, I can write like this. You know that ABB power n, I can write like this, ABB power n minus 1, ABB. Okay, then this is B inverse. So B inverse B is equal to E. So we have proven it. We have proven that if BAB power n is E, then ABB power n is also E. Can you prove the other side? Can you prove the other side? Can you try the other side? Okay, let's try the other side. So what is the other side we need to prove? Please try. Take your copy pen. The second thing we have to prove is if ABB power n is E, if ABB power n is E, then prove that BAB power n is also E. Then prove that BAB power n is also E. Okay, just prove it. Can you do it? This will be very interesting. Just do. If ABB power n is, means this is given to you. Okay, this is given to you that ABB power n is E. Is E. Okay. So if you write it, if you open it, means I can write it like ABB, ABB, ABB. If I open it 5 times, just think about it. If I open it 5 times, let's assume, means if I open it 5 times, then how many BAB I am getting? How many BAB I am getting? I am getting BAB, I am getting BAB, I am getting BAB, I am getting BAB. So this BAB I am getting. How many times I am getting this BAB? 4 times, right? I'm getting this 4 times. Means what I'm getting AB, then I'm getting BAB 4 times, and then I'm getting B. So the same thing will happen if I open it n times. ABB power n, if I open it n times, then same thing will happen. ABB, ABB, ABB. If I open it n times, ABB, that is equal to E. If I open it n times, then I will get this AB, then I will get BAB power n minus 1, and then I will get B, that is equal to E. Okay, from here, you tell me. So now from here, we will see. And what we need to prove? We need to find. Now what we need to find? Now find what we need to find. Now we want to find what is BAB power n, right? Agree? Now we need to find. Now find BAB power n. So let's find BAB power n now. So what that will be? BAB power n. See, I can write it. This BAB power n, I can write it BAB power n minus 1 BAB. Okay. Now you can see this BAB here. I can write it BAB, or I can simply write it like this. Either I can write like this. Okay, there is no problem. So tell me, what is BAB power n minus 1? Or what I can do, or I can do this. See, this BAB I can write here. For simplicity, for quick, I can say this. BAB I can write here, because I can do this. You know that BAB power n, I can write like this. I can write that BAB and BAB power n minus 1. I can write like this. Now, this we have. What is AB power? What is AB BAB power n minus 1? Okay, please focus here. What is AB BAB power n minus 1? See, what is AB BAB power n minus 1? This one. Focus on this. This. So tell me from here what I can say. I can say AB BAB power n minus 1, that is equal to B inverse. Agree? That is equal to B inverse. So this is equal to B inverse. So you got B inverse, that is equal to E. So what you have proven? So what you have done? Please tell me. So you have proven that if ABB power n is E, then BAB power n is also E. This is what you have proven. So hence proved. Agree? Do you agree that? Hence proved. So we have proved that their order is same. So we have proved that their order is same. Order of BAB is same as order of ABB. We have proved it. Please tell me, did you find this interesting? See, in the quiz, if you are not able to solve this question, don't worry about it. Okay. The purpose of quiz was to make you think. Okay. That was the purpose of the quiz. In the quiz, you don't have to get the full marks. Okay. The purpose of the quiz is to make you think. In the quiz, if you are not able to solve this question, that is fine. That is fine. But now did you understand? I'm asking, now did you understand? Now can you solve this type of questions? Now if I ask you, order of X is equal to order of Y, this type of questions if I ask you, can you solve? Now if I ask you, order of X is equal to order of Y, this type of questions if I ask you now, can you solve? Please tell me. Can you solve them? Now did you understand? Very simple. So this proof, did you understand? Interesting, right? Simple things are happening. Some simple things we are doing. Step by step we are doing. So did you understand this proof? So yes, they have same order. And this is also correct. So answer will be, the question is asking true statement. The answer will be both 1, 2. Okay. So this is, I can say, interesting question. This is not an easy question. This question is not easy question. But I'm telling you, in this question, you will learn a lot of things. Those questions which you are not able to solve in the weekly quizzes or in the test, those questions which you are not able to solve, these questions will improve your knowledge. Remember one thing. Okay. If you are already able to solve the question, some question is there, if you are already able to solve it, then that question will not improve your knowledge. Your knowledge will be improved by those questions which you are not able to solve. Okay. Like this question will definitely improve your knowledge. Okay, let's move on. So let's see this question. So I think the remaining questions we can discuss tomorrow. Shall we do that? I think this is enough for today. Whatever analysis we have done today, just think about it. Some very good questions we have seen. Some new things we have seen. New concepts we have seen. Actually, not new concept, new strategy we have seen. Okay. All the concepts we have already seen in the lectures. Okay. There is no new concept. Every concept we have already seen in the lectures. But these are, I can say, new ways of thinking. How you can think. So some new questions, some new approaches, some new strategy. So that we have seen. I hope you are learning something new in this session. Did you learn something new? Like, are you finding group theory interesting? That, yeah, this is interesting. Okay, I'm learning. So now I'm finding this group theory very interesting. Whatever question will come in the GATE exam or in the TIFR exam, in any exam, whatever question will come, I can solve it. Please tell me. Let me know your feedback of group theory. So the remaining questions we will see tomorrow. Okay. Tomorrow we are going to solve the remaining questions. The remaining questions are also very nice. Some very nice questions are there. Like this is very nice question. It is impossible to create Kelly group. For which of the structure? For which of the structure it is impossible to create impossible to create a group? So this type of questions also we will see. So tomorrow the remaining questions we will solve. Please tell me, so far everything is good? Okay. So thank you everyone. The remaining questions we will solve tomorrow. Thank you.